So that's what's happening now in the circuit is we've got base current causing a collector current, which will cause an emitter current or emitter voltage to be present. And all of those are present around the Q point. So first thing we have to do when I analyze this circuit is to do a DC analysis, Q point. Okay? So the bottom of page 2 is all about the DC analysis, which is the Q point, and that is the same calculations I've done in the last couple of classes with a voltage divider, because that's what I have here, a voltage divider. On page 3, I show AC analysis, which has at the top an AC emitter resistance. I'll talk about that in a second, followed by the equations for 4 cases, case 1, case 2, case 3, case 4, which is the voltage gain, which is what an amplification is all about, which is how big the signal is becoming, which is called gain, right? Input signal is small, output signal is big. Is that a gain?
Yeah.
Right? So that's what those 4 equations are. And those 4 cases are primarily this. If I have a load connected here, that load can be one of 2 things. It could be another amplifier circuit, in which case this could be like a preamp. And then another circuit might be a regular amp. And then another circuit might be a power amp. Okay? So in the old days, not that old, you can still build these. You will have one stage called a preamp, followed by another transistor circuit, which might be boosting that signal a little more, followed by a power amp to drive a speaker. Speakers require a power amplifier, right? So then that load might be a speaker, for example. Okay, so we're going to analyze this amplifier circuit with and without RL, and with and without C bypass. That's the 4 cases here. Case 1, case 2, case 3, and case 4 are with or without RL, with or without CB. Okay? So that's the background. Now let's go to page 4. At the top of page 4, we talk about an AC emitter resistance. This AC emitter resistance is here. And it's special. It comes into effect when I have an AC signal. So the AC signal causes this PN junction between the base and the emitter. The resistance there is labeled R prime E. And that is going to be present anytime I have an AC signal. So that's called the AC emitter resistance. And it works out to 25 millivolts divided by IE. Okay, where IE is this current here, and 25 millivolts is a constant. What do I mean by a constant? It's like gravity. Is gravity a constant? Same thing. This 25 millivolts is a constant number. And if you go to Appendix 2 for just 1 second, Appendix 2 is on what page? 17. It talks about the base to emitter PN junction and the emitter current. There's a lot of calculus involved. And at the bottom of page 17, the Appendix 2, it talks about the voltage over the current in this PN junction, which is resistance, and it becomes 1 over 40. 1/40th of IE, okay? And so that simplifies to 25 millivolts over IE. Some places you'll see 26 millivolts. Some places you'll see 30 millivolts. But we're going to use 25 millivolts because our textbook uses 25 millivolts. Okay? So that's R prime E. And we're going to use R prime E in my calculations under voltage gain. So that's where it comes into picture. DC beta and AC beta, figure 4. Figure 4 talks about DC beta and AC beta. We have talked about DC beta, which is IC over IB, right? Beta, DC, HFE, DC is IC over IB. So the first graph there shows DC beta. IC on the y-axis, IB on the x-axis. If I was to calculate, now that I have an AC signal, then I have this fluctuation. I've got this delta IC and delta IB. So then beta AC is going to be delta IC over delta IB. So it shows a small IC on the y-axis and a small IB on the x-axis. For most calculations, if you're at about a 45-degree slope, then this beta DC is approximately equal to beta AC. Okay, so there isn't much difference between the two. There might be a small difference. Okay, this brings us to page 5. The capacitors in an amplifier circuit. So let's talk about the capacitors in an amplifier circuit. How many capacitors do we show in this amplifier circuit? 3. Capacitors, you know, work by the equation XC, which is in ohms, is equal to 1 over what? 2 pi FC. Right? So we know that a capacitor is sensitive to frequency and to the size of the microfarad value. Let's take 2 cases. Frequency or DC. If I have a DC circuit, what is the frequency? 0. I've got a flat value, right? 9 volts. Is there any frequency to the 9 volts? No. It's flat. So if I put 0 in this equation, XC, 1 over, if F is 0, is my whole denominator going to be 0? 1 over 0. 1 over 0 is the same thing as 1 over a very small number, right? 0 can be 0.000000001. So what does the answer become? A very large number or infinity? A very large ohms value, is it the same thing as an open switch? Does an open switch have infinite resistance? And am I talking about resistance here? So